We've got all visible the solar device pics in textbooks. The Sun, slightly larger than Jupiter. But that is not the proper depiction of the scales. The Sun is so big that you may match approximately 1,000 Jupiters inside. Amazing as it is, our Sun is not the largest star within the universe or maybe our galaxy. That name is going to UY Scuti, and in comparison to it, our famous person is sort of a tiny pebble. However, there's greater. Scientists have stumbled upon something even extra mind-boggling, an enigmatic historic star with a black hollow internal. It is an astronomical mystery that both puzzles scientists and may probably explain how the universe got here to be what it's far nowadays. However, how is it feasible for a black hole to exist internal a celebrity? Why had been those stars so tremendous? And what would take place if a black hollow famous person wandered into the solar device? Stars are like cosmic blacksmiths. In their fiery cores, they're forging the general public of the elements we take a look at in the universe. However, the stars that could have existed at the very beginning of the universe were something specific. In preference to conventional stellar cores, they harbored black holes within, letting them grow to not possible sizes and past. Everyday stars arise from clouds of gasoline and dirt as gravity makes the densest regions of the cloud crumble. The ensuing mass of cloth heats up and creates a protostar, an early stage in the evolution of a star. Eventually, the newly formed warm middle accumulates sufficient remember from the encompassing rotating disk of gas, becoming a primary collection famous person that starts generating power through nuclear fusion. It took our solar approximately 50 million years to reach this section. The majority of stars will spend maximum in their lifespan as most important series stars. However, finally, they'll all either come to be white dwarfs if their mass isn't big sufficient or pass supernovae. After a star blows up, it can come to be as a black hole or a neutron famous person, and the direction it takes depends on how big it turned into. When our Sun runs out of hydrogen in approximately 5 billion years, it will grow to be a purple large, increasing 200 times in size earlier than in the end, shedding its outer layers and remodeling into a white dwarf, a celestial object that's more or less 200,000 instances denser than the Earth, however approximately the same length. This dense sphere will then slowly cool to about 18 million ranges Fahrenheit, 10 million degrees Celsius, and in about 10 billion years, the white dwarf solar will crystallize. The technique is really just like how water becomes ice, even though the material is exclusive. Within the case of the solar, it will be carbon and oxygen solidifying. Stars over 10 times the mass of the Sun could have a different destiny. They're large sufficient for their cores to disintegrate after a supernova. However, they lack the mass required to turn out to be black holes. So wherein does this go away them? Deep inner those stars, the intense pressure squeezes each proton and electron so tightly, they merge to form neutrons. Neutrons cannot be compressed any similarly, so they counter gravitational stress, and the celebrity unearths a brand new stability. Neutron stars are the densest items inside the universe apart from black holes. They may be just the dimensions of a small metropolis more or less 12 miles, 20 kilometers. However, nonetheless have a mass of the Sun. On the planet, neutron big name fabric, the scale of a sugar dice would weigh as a good deal as 1 billion tons, about as heavy as a mountain. However, how do stars come to be black holes? Whilst the famous person remains active, the two winning forces paintings against each different nuclear fusion, and the acute gravity created via the big name's personal mass seeking to squish it. Once there may be no gas left to electricity nuclear fusion, there's not a force to counter gravity, and the superstar collapses in on itself, just like the controlled demolition of a concrete constructing. Einstein believed that something should grow to be a black hole if it had sufficient mass and become compressed internal a sure radius. Black holes hold on growing all through their lifespan, devouring any material that receives too close. When this occurs, the region in which gravitational pull will become so strong that not anything can break out increases, and the black hollow consumes even more nearby material. It's truly like the sinking of ground due to the crumble of underground systems. Although with black holes, it's far a gravitational sinkhole, step by step accelerating as its occasion horizon grows. Generally, black holes have a restrict on how fast they are able to extend. This takes place because of something referred to as the Eddington luminosity limit. Basically, it's the factor at which a black hole can't take in fabric quicker than it already does. If you were filling a vehicle tire with air, and it had small holes in it, the increased strain inside would make some of the excess air escape. In space, something comparable happens with rotating black holes. As B counted spirals toward a black hole, it is going faster and faster. Because of this, about 42% of this count may be converted into strength. And this radiation is so powerful it can push some of that incoming fabric away, similar to an automobile tire pushes the air away. This manner is so efficient, the radiation emitted away surpasses the electricity output from nuclear fusion in stars. Just believe a future in which we find a manner to harness this strength and use it for our wishes. Even supermassive black holes with a large surface region that draws count number have this restrict. They are at the center of almost each galaxy out there, and a number of those supermassive black holes have been recently located to be plenty larger than we notion. That's one of the greatest mysteries in astronomy. The sluggish accumulation of depend over the age of the universe fails to give an explanation for their considerable length. However, there's something that would get to the bottom of the thriller. Black hole stars or quasi-stars need to have been the biggest celestial bodies to ever exist, dwarfing even the most gigantic black holes we've discovered up to now. These days, the conditions of the universe do now not permit black hole stars to form. However, at the start of time, space become filled with big gasoline clouds. Within those dense areas of space, cloth collapsed in on itself under its very own gravity, and due to the fact there has been so much greater of it, it piled up, giving upward push to baby stars of extremely good importance. Even though there's an idea that they will have originated from dark matter halos, invisible round regions of dark matter of as much as 100 million solar hundreds, wherein hundreds of supermassive stars should shape. But these celestial giants weren't simply big, they were so large, their size allowed them to take in the explosive force that would in any other case shoot the big name's outer layers out into area. Rather, those ancient stars simplest experienced implosions, which transformed their stellar cores into tiny black holes at the same time as retaining the outer layers intact. If you could by some means take a look at this phenomenon from a close distance, you wouldn't even notice any modifications with the celebrity. Now that there's a child black hole inner a quasi-star, it starts consuming it from the internal. At this point, the black hollow is tiny, but it's spinning, and this creates a disk of hot material circling it at almost the speed of light. On top of that, there's now not a restrict on how fast it can eat gas because the superstar's pressure sends it immediately into the black hole. The friction inside the accretion disk turns into warmer and hotter, emitting heaps of radiation and making the host celebrity glow like a small galaxy. Quasi-stars, if they existed, grew quicker than any black hole we've ever found. Eventually, within tens of millions of years, a number of them might beat the largest stars and black holes in size that we realize approximately, like Stephenson 2-18, UY Scuti, and TON 6-18. Just how huge is that? From lots of times large than the solar to probably even the diameter of our solar machine and beyond. However, this gargantuan size and mass additionally causes troubles. The bigger quasi-stars grow to be, the shorter their lifespan. Our solar has been around for over 4 billion years, with approximately 6 billion years left in its lifespan. Whilst black hollow stars lasted for only a few million years earlier than spectacularly exploding with exceptional strength, liberating an ever-hungry vast black hollow ready to float across area in search of extra cloth to gobble up. However, what if a star like this wandered into our peaceful celestial neighborhood? As soon as a quasi-big name located its way into the solar machine, its gravitational impact would disrupt the hooked-up orbits of planets and celestial bodies. The as soon as orderly planetary system could be in overall chaos, with Earth experiencing an extreme asteroid rain. The results would begin earlier than the quasi-superstar entered our solar system absolutely. Because the giant star swallows the outer planets and different celestial bodies, our planet might already enjoy a surge in temperature and luminosity, making the surface inhospitable, till subsequently, it might devour the Earth too, despite the fact that existence right here could lengthy be long gone by then. The principal black holes inside quasi-stars should have served as seeds for the formation of supermassive black holes which might be on the facilities of galaxies these days. And they could have even performed a bigger role. The dynamic processes related to quasi-stars, such as the crumble of the important black hole and interplay with the encompassing relay, can be strong resources of gravitational waves, which in turn, may also have performed a position inside the formation of galactic systems and the distribution of stars within galaxies. Quasi-stars may want to have implications for astrobiology. The extreme radiation from these items would possibly have affected the habitability of planets of their location, doubtlessly shaping the conditions for existence in surprising ways. Within the context of cosmic evolution, quasi-stars may have set the destiny via shaping the early universe in unthinkable approaches. However, right here's every other thoughts-blowing idea for you. Despite the fact that there are possibly no quasi-stars in our universe these days, tiny black holes, kind of the mass of an asteroid from the dawn of time, would possibly still be right here. Theoretical physicists speculate that, if such black holes had been abundant, they could be drifting round space, once in a while ending up trapped inside gas clouds. There, as new stars might be born, primordial black holes might subsequently locate their way into the celeb's cores. Even black holes the mass of Pluto would grow, particularly within just a few 100 million years, a relatively quick time frame in a star's evolution. So even our sun may want to have one, which the awesome overdue Stephen Hawking as soon as suggested. If it hit a black hole approximately as massive as Mercury, we wouldn't even note it, even though it's very unlikely. However, there's one technique scientists think might help perceive such cosmic bins for primordial black holes. For one, the so referred to as Hawking stars might be an awful lot extra long-lasting. And to chill off, Hawking stars amplify into purple giants, something our sun will do because it a while. But red giants with a tiny black hollow interior could be a chunk cooler than they usually are. Researchers have already detected about 500 abnormally cool red giant stars. To discover whether or not those stars conceal primordial black holes within, scientists plan to take a look at the stars' specific vibrations as they pulsate, which can characterize they certainly aren't normal crimson giants. And here's some other thought-bending thought for you. Some accept as true with that the mysterious dark count that prevails inside the universe is in fact a swarm of miniature limitless primordial black holes. And so at the same time as it's extremely implausible that a black hole like that could emerge as captured through a celebrity, if there's an immeasurable range of them, at least a few might. We'll must wait till scientists figure that out for us. However, for now, that's all of the time we have. Live tuned here for more interesting cosmic mysteries and fascinating discoveries. Let us recognize what you think about the enigmatic quasi-stars inside the remarks underneath. We read all of them, and thanks for watching. The realm of cosmic phenomena extends far beyond our typical understanding of stars and black holes. One of the most intriguing aspects of modern astrophysics is the notion of primordial black holes. These hypothetical objects are remnants of the early universe, potentially formed immediately after the Big Bang. Their existence is hypothesized to address several outstanding questions about dark matter and the formation of cosmic structures. If primordial black holes are indeed scattered throughout the universe, they could offer crucial insights into the very fabric of our cosmos. Primordial black holes are thought to have formed from the density fluctuations in the early universe. These fluctuations might have been significant enough to cause certain regions of space to collapse under their own gravity, leading to the creation of black holes with a range of masses. Some theorists propose that these black holes could be as small as an asteroid or as large as several solar masses. Their potential impact on cosmic evolution is profound, especially if they are tied to the mysterious dark matter. The existence of dark matter is one of the greatest puzzles in astrophysics. While its presence is inferred from gravitational effects on visible matter, it has not yet been directly detected. If primordial black holes constitute a significant portion of dark matter, it would revolutionize our understanding of both dark matter and the formation of cosmic structures. These black holes could contribute to the formation of stars and galaxies, influencing the distribution of matter on a grand scale.